Okay, in this tutorial we're going to be looking at modelling and applications. Okay, this is really our bread and butter of our work. We really need to be able to do these type of tasks, and they're usually not too bad, but it's certainly an area that we need to focus on. So really, there's not much to it other than really having a crack at some worked examples, to be honest. So basically the idea is, so we'll either have a set of data or we'll have an equation that models a real world situation and we're asked to analyse it in some way. Okay, so we're looking at work example 21 and we're told that the population of foxes on the outskirts of a city is starting to increase. Data collected suggests that the model for this number of foxes is given by n of t equals 480 minus 320 e to the negative 0.3 t, where t is bigger than or equal to 0. Okay, and so t is going to be time, so n is the number of foxes and t years after the observations began. Okay, now first question is, how many foxes were present initially at the start of the observations? Really difficult question. We like to know an initial condition. Okay, so that's when we let t equal 0. Okay, so we're going to let t equal 0. And we get n of 0 equals 480 minus 320 e to the negative 0.3 times 0. Okay, so our e to the, our negative 0.3 times 0 is going to be 0, so e to our 0 is going to be 0. So it's going to be 480 minus our 320. So our number of foxes initially is going to be 160. Okay, and our next part is by how many had the population of foxes grown at the end of the first year of observations. Okay, for this time, what we need to do after the first year is work out what n is when t equals 1. Okay, so this time we're going to work out n of 1. Okay, and that's going to be 480 minus 320 e to the negative 0.3 times 1. Okay, at this point really it's just a calculator job. Okay, we won't be asked to do anything more with this. Okay, we don't want an exact value, we want a decimal answer. Okay, so when you put that in your calculator, we end up with 242.94. Okay, which means we need to round up to 243 foxes. Okay, our next part is, after how many months does the model predict the number of foxes would double its initial population? We're going to double our initial population. So this time, okay, we're letting nt equal 320 because our initial population was 160. Okay, so now we want to find out how long it takes to get to 320. So you can say, hey, we've got 320 equals 480 minus 320 e to the negative 0.3 t. Okay, now we've got to solve for t. So take away our 480. Okay, so we've got negative 160 equals negative 320 e to the negative 0.3 t, and divide by our 320, which means we're going to get a half equals e to the negative 0.3 t. Okay, at this point in the course, if you haven't actually done much work with changing between exponentials and logs, we need to use our calculator. Okay, but what we can do is we can manipulate this so we get log to the base e of a half equals negative 0.3 t. Okay. Which means we would then have to divide by a 0.3, negative 0.3, so t would equal log to the base e of a half divided by our negative 0.3. Okay, but it's quite acceptable to use your calculator to solve it at this step. Okay, which will get t equals 2.31. Now we've got to be careful there, because that's not our answer. Okay, because that's our answer in years, but the question asks for it in months. Okay, so we've obviously got our 24 months from our 2 years, and we just need to do our 0.31 times 12, okay, which is approximately equal to 4 months. Okay, add that on to our 24 months, okay, we get 28 months. Okay, and even textbook end up getting that one wrong, because they left it as 2 years and 4 months, but it asked for it in months, so it should be 28 months afterwards. Okay, we need to now sketch it, sketch the function. Okay, and given this question assumes that we have to use the technology, then there's no reason why we couldn't sketch it using technology first. Okay, but we don't need to worry too much. We can do most of this. Remember, this is one where we've got a negative out the front and a negative up the top here. So our shape is going to be this way. Okay, remember, we don't need to go anything in our negative values. Okay, and this should be n, and this should be t, not x and y. We know t starts at 0. Okay, we also know, okay, our shape is going to be this way, which means we'll have an asymptote. Okay, it usually would be down here, but it's going to be moved up by 480. Okay, so that's 480 there. Okay, and we know our initially we had 160. Okay, so that might be there, 160. Something like that. Hey, and in E, our last part is explain why this model does not predict population of foxes will grow to 600. Now basically our model shows, due to this horizontal asymptote, that the population will approach 480 but won't exceed that at all. So there's no way that this model predicts that it'll ever reach 600. Okay, so that's the only worked example we've got to have a look at. Okay, so again, the main thing is just to remember our initial conditions is always when our t or whatever our variable is in this part of our equation when that equals 0. Okay, that's one of the biggest parts for these type of questions.